So the page that I'm on now is the page that relates to instantaneous rate of change. It looks a lot like the one that we did on yesterday. It starts off talking about rate of change as being the change in one quantity, the dependent variable, with respect to change in another quantity, independent variable. That there are two types, instantaneous and average. Yesterday we did average. Now, the difference now is that when we're doing instantaneous rate of change, I don't give you 2 points anymore. I give you 1 point and say, what is the change at that specific time? Or not necessarily time, but at that specific point. And it's just like one of the things that is a rate of change is velocity. You're going down the highway and you're changing your position in relation to time. So as time is moving, time will be the independent variable. Your position on the highway is also changing. And that's why when you're on the highway, you see them quoting the speed limit. The speed limit is 100 kilometers per hour on the highway. When you look at the speedometer at a particular time, it gives you the velocity at that particular time. So it will say you're traveling at 60 kilometers per hour if you slow down, since its limit is 100 kilometers per hour. Or if you are going too fast, maybe 120 kilometers per hour. And that is the rate of change that you're experiencing at that specific time. And that's like what we're going to be looking at today. What is the instantaneous rate of change? You're not looking at the time between 5 seconds and 6 seconds or between 5 seconds and 10 seconds, right? That's an average over a period, over a certain interval. Now we're saying what is the actual velocity at a specific point in time. And that's what this is all about. So instantaneous rate of change, what I'm pointing to now, is a rate of change that takes place at a specific point. So you're probably thinking, how am I going to figure out a slope when I only have 1 point? Well, to be totally honest with you, the way that's done in the real world is using calculus. But this is not a calculus course, this is a pre-calculus course. So what I'm going to show you today is kind of an approximate instantaneous rate of change. It's not as sophisticated as calculus. So mostly going to go on to calculus and get more sophisticated tools to do this. But for this course, which is a pre-calculus course, we're going to give you a less sophisticated way of finding this slope at a specific point. So that's why this says tangent can be approximated by a secant line that just touches the graph of the function. And we call that graph that just touches the graph at a particular point a tangent. So the slope of the tangent is a point on a graph that represents instantaneous rate of change at that point. And we're going to use this formula to be able to figure it out. Now, it's a complicated looking formula, but we're going to simplify it for you in a little while. F of x plus h. I'm teaching my calculus course. I have calculus in the mornings, by the way, and we're using this exact same formula right now to use to figure out slope. But the h in this case for you, for this course, is just going to be some very small number, like a 0.01, a 0.001. My advice is that you use 0.01 when you're doing these calculations. And you'll see what I mean when we start going through the exercises. But here are some tangent lines to give an idea of what I mean by a tangent line. A tangent line doesn't go through the function like a secant line does. Let me take you back to a secant line for a second here. Here are some secant lines that go straight through the function and touch it in more than one spot. So a secant line would maybe touch it here and here, then we can find the slope of the secant line, and that's fine. But now we're talking about something which is a tangent, and therefore it just touches the function, just grazes it on the edge right there, just grazes it right there. And I want to compare that to a wheel, or a circle, I should say, which is sitting on the ground. Well, I guess you could say a wheel then. And that circle or that wheel is just touching the ground at one spot. So this one little spot right here is where the wheel is touching the ground. It's not touching it anywhere else. It's not like it's going through the circle. It's just touching the circle at that one little spot. And we're going to call it a tangent line. Okay, so this line, this line that represents the ground, we're going to call it a tangent line. So it's the same thing as the line that's just grazing the edge of the the function at different points. That's what we call a tangent line. Okay? So there are a few ways that we're going to get this instantaneous rate of change at a particular point. One of them is by looking at a graph and trying to draw that tangent line on the graph. We're going to be doing that in a few minutes. Another one is to look at a table of values and take values that are very close to the point that you're trying to figure out what the slope is. And the third one is by using the equation, if you have the equation, and estimating the slope using a very short interval between the tangent point and the second point found using the equation. And that's where this 0.01 is going to come in handy. Some people use the 0.001, but I just think that's a little bit, too much work. So I just go with the 0.01. I just think that that's good enough. All right. The fact is that it is only a very sort of unsophisticated way of getting the slope anyway, but I think 0.01 does a pretty good job. Okay. So here's what we're going to do now, right? You're all going to do this with me. You can see on the screen that I have a graph. I haven't given you the equation of the line. I've just given you a graph. You're going to be doing this along with me. You're going to draw a tangent to the graph at x equals 4. So x equals 4, here's where 4 is. I can make this a little bigger for you in case you're not seeing it well enough. I'll zoom into 300%, right? And you can see that at 4, the value of the function is 7. So I'm not asking what the value of the function is. That's not what I'm trying to ask you. I'm trying to ask you to put a line that just touches the edge of the function right there at 4. I don't want that line to go through the function. I think I'm going to have to zoom back out a bit. And I think it's easier for you to understand is if I zoom out some more. So what I'm saying is that this graph, let me go back up here. This graph that I'm drawing has a slope right at 4. So here's what I'm going to ask you to do. You can just use the screen that you're looking at right now to do this. And I'm going to use a line myself. I'm going to try to draw a line that is just going to hit, and my goal here is to hit that 4, right? Just the 4, but nowhere else with a line. So I want a line that kind of just kind of, and that line, the line I'm drawing now is good enough. I'm going to have to fix it a little bit. I want it to just kind of touch the edge of the function at 4. I want it to be a tangent line, right? So there's one possibility right there. But I want you to do your own, right? Don't use my line. Use your own line. Put a line. You're in front of a screen right now. Use a ruler or some other device to put a line along the edge of the function that just touches at 4. And then pick 2 points on that line that are easy to read. So if I just had this, if I just had any line, I just put a line here, and I'm not going to sort of give it away by making it the right slope. But let's say I had a line that was like this, right? And I want to find the slope of this line. Let's say it was up here. This is not a good line to use because this line is not actually just touching the axis at one spot. It's just an arbitrary line. If I had a line like this and I'm trying to find the slope of that line, what I would do is I'd say, okay, I'm trying to find 2 points I can easily read. Let me make the line longer, actually. I'm going to look to see if I can find 2 points I can easily read. And I'm thinking, okay, here's 1 point that's right about here. And here's another point that's maybe here. Maybe I can use those 2 points. And I'm going to say I can find the slope by using rise over run. So how far down I went, that's my rise or my fall, over how far across I went, right? That'd be my slope. So 1 point is at 2.6. And the other point seems to be at 9.1. Right? Find the slope by subtracting them. So 2 minus 9 is what? Minus 7. And 6 minus 1 is 5. This slope would have been something like 5 over minus 7 or minus 5 over 7. Let's put a minus on top. So I want you to do the same thing, right? I'm going to erase all of this. I'm going to take away this line. And I want you to use your best judgment on the screen right now, right? I won't be able to see how well you're doing it because I'm not on that end of the of the camera, not front really the camera of the screen. You're going to put your line, you can use a ruler to draw a line up against the screen, which is sort of, and what I would suggest you do is just find a ruler, right? Use a ruler. Put it. Let me get rid of all this writing that I have on here. All right. All right. Let's get rid of that. And you find a line that's able to just touch the ground. This line is not good because this line is going through the function. What I want you to do is put a line and you line it up in such a way, right? You do it in such a way that it just grazes the function at 4. Sorry. It just grazes the function at 4, right? It just was right on the 4 line. Then find the slope of that line. Whatever that slope is, I want you to work that out. And I'm going to get from you a quick sample from everybody as to what they got. Is everybody clear on what I'm asking you to do? So use the screen as it is. If you want to use a ruler, right, that might be a bad idea, right? I have a ruler in my smart board here. If I can remember where it is. Insert measurement tool, ruler, right? So if I had a ruler, I try to put it and just touch the edge of the function there and then try to find the slope of that line. That's what I'd like you to do. Okay? All right, go, everybody. I'll take this away so you can have all the space to put it up against the screen and tell me what you think the slope of that line is. And I think you can probably appreciate that the slope of this line is probably going to be negative because the function is actually falling on this side. We were looking at average rate of change yesterday, and we figured out that when the function is going down, it has a negative slope. So because at 4, the function does seem to be falling, I would assume that, because you already hit the peak and you're on your way down, I would assume that we could probably find a negative slope out of that. So you're on your own now for about another minute or two. Come up with that slope if it's just touching the 4. I'll just put a little circle around the 4 there, right here. I need you to just touch that point and then find the slope of the line. Okay? All right, so I'm over to you now. So, Keontae, you were one of the first ones out of the gate, so I'm going to use yours. I'm just going to use the initials KEY. Can you tell us what you got? I'll take a few more after that. Can you tell us what you got 1/6? I'm hearing. But that should, oh, so why don't I put -1/6? Because I'm sure it's all better if you put the minus on the numerator. Okay, is that reasonable? Reasonable? Okay, good. All right, so that was Keontae's version of things. Let me come over here and see if I can get somebody else, like maybe Harish, to give me his version of it. Harish, what do you have? You got -3/10. Okay. Thank you very much. And let's see now. That was Harish. How about if I got the same thing from Rylan? Rylan, what do you have? -2/9. All right. I'll take 2 more. How about Karis? Karis, can you give me what you have? Oh, Caleb has, okay, hang on to that one for a minute, Caleb. Karis has -1/4. It's at least good that everybody's getting something negative. Okay, Caleb, you have -1/4 as well, Caleb? Okay. I'll take one more. Anybody, just anybody, give me what you have. And let's see, -7/2, -2/9. Okay, let me put both of those in. So Noah, -2/9. And AXA is -7/2. That's supposed to be a Q, sorry. -7/2. And I have another one from Janaya who got -1/4. Okay. All right, we'll leave it at that. -1/4. Now, for each one of these, you have a corresponding decimal. And I'll tell you what the actual number is in a while. We'll get to the actual number in a while. But if you put these into decimal format, I can roughly do this in my head. All right. The Keontae one was approximately -0.17. Right. I know that that's what -1/6 is. The Harish one is -0.3. Right. The Ryland one is minus 0.2. The Caris one is minus 0.25. All of these are minus numbers. Caleb and Caris have the same thing. Noah has the same thing as Rylan. And AXA is minus 7 over 2. So that's approximately minus 3.5. And Janiah has the same thing as Caleb and Caris. Now, are these all roughly the same? Or is there one that's a little bit odd out of all of them? Right? Is there one that's a little bit out? I'm going to have to say that the AXA one, I think the wrong integer, Keonta thinks. Yeah, yours is a little bit low as well compared to those 0.3, 0.2, 0.25. The minus 3.5 AXA, I think you might have it the wrong way around. I think you might have wanted to put maybe 2 over 7, perhaps. I don't know. But 7 over 2 would be minus 3.5, which is a little bit steep. This looks fairly flat the way at this point right here. Right? Do you see what I'm saying? So you might have it, maybe you should have put it the other way around. But I would say that people are getting in the minus 0.3, minus 0.2. This is actually minus 0.2 as well, approximately, if you round it. So I would say that that's not too far from minus 0.2. So the between minus 0.2 and minus 0.3 are all fairly reasonable estimates. Now, that's one way to do it. Right? That's eyeballing it. If anybody got 0.5, I'd say, no, I don't think so. 0.6, 0. No. And I'm saying minus 3.5 AXA, no disrespect intended, not trying to discern anything. But I would say that's a little bit off the mark there. But anything in the region of about minus 0.2 seems to be fairly reasonable. Now, there is an actual, if we're using calculus, something as sophisticated as calculus, there's an actual number that we would get from it, but just hold on to that for a minute. I also have a table of values here. I want you to look at that table of values. When it's 4, it's at 7. We already knew that. Now, there are values that are pretty close to 4. 3.9 on one side, 4.1. You don't have the equation. You don't need the equation right now, right? I'm just showing you. There are points that are fairly close to 4. There's at 3.9 and there's 4.1. Both of these are just 0.1 off. What if we just simply used either one of these very close points here, along with the 4, 7, along with this point to get that Iroc, because it's so close that it's almost like it's a tangent. So I'm picking 2 points that are actually on the line. So one is actually at 4, 7, this point right here. And another one is so close to it that it's almost as if I was using a tangent line to connect those 2 points. Then that might give me a reasonable slope. So that's what we're going to do right now. We're going to use a point on either side, either the one that's just above or the one that's just below. Right? I'll use the one that's just above it, the 4.1, which is 6.97, whatever it is. I'm going to use that as my comparison point. So we're going to find a slope between both of these 2 points here, right? And what we're really aiming for is the Iroc at 4.7. So here's what I'm going to do. I'm going to set up a slope calculation. My Y value for 7 is 6. Actually, let's put the 7 first. Let's do the 7 first, actually. Let's go to black. So I know, remember that people were getting it backwards yesterday. I want to put the 2 Y values on top of each other. So I'm going to put the 7 minus the 6.9795. Then I'm going to subtract the 2 X's. Which one gave me the 7? Was the 4. So 4 goes first, minus the 4.1. So I'm matching up the 4 with the 7 and the 4.1 with the 6.975. So the one that came first is the 7. So I'm going to put the 4 first because the 4 gave me the 7. The one that came next was the 6.975. That came from the 4.1. That's why I have them in that order. Okay, so let's do a little math here now. The top of this, by my math, is 0. Let's see now. Let's see, that should be 5, 0, 2, 1. Is that right? You all have the calculators there. Just help me out with that, please. Is that what you're getting, or did I do 0.205? I think you're right. 0.205. Thank you. I believe you're right. 0.205. Oh, you've done the whole thing already. You've divided it by 0.1. You divided it. So the bot, okay, I think you've done the whole thing already. So this was actually 0.025, I think is what it was, right? Yeah, I think that's what it was. 0.0, yeah, right. Okay, so the top of this, yeah. I just wanted to make sure I did that right. So the top of this is 0.025 divided by minus 0.1. And because I'm dividing by that, I just move the decimal point 1 over. So 0.205, and that's still negative. So approximately 0.21. Approximately 0.21. Okay? Now, so your values that you got, which are in about that minus zero point 0.2 range, were actually not that bad, right? They're not the most precise tools, but they're actually not that bad. If you're getting like 0.4, 0.5, as I said before, that's not good. 0.1, still not good enough. But anything in the zero point 0.2 range, and I could certainly think that the 0.17 is in that range. 0.3 is not bad. 0.2 minus 0.2. The only one that was a little bit questionable was this one here. And Axel understands why her numbers were a little bit off. But everybody else was getting numbers that were in about the same range. If we did it the other way, doing it with the 3.9 and so we could have done it with this same red box and the 3.970195 above it, we'd get another similar answer to the minus 0.205. Okay. All right. So Kayla has 205. It's not 205 though. I don't know if I agree with that though, Kayla. It's minus 0.205. You see what we're saying? Oh, oh, okay, got it, got it, got it, got it, got it. Okay, great. Okay, so there you go. So there are two methods that we just did. One is if we have the graph, we estimate it by trying to draw a line and picking 2 points, and then with those 2 points, we can get a slope. Another one, if we have a table of values, pick two that are, I wouldn't use the 3.5 and the 4.7. I want to find out the 4. I want something that's as close as possible to 4. And the only two that are close to the 4 are 3.9 and the 4.1. So I wouldn't use a 4.5, I wouldn't use a 3.5, they're too far away. I would use the ones that are closest together to find that Iroc. Okay? But there's another way that we can do this. I'm going to ask you now, we're going to do this one together. Determine the slope of the tangent to the function at the point minus 1, minus 9. So, again, this is different from yesterday because yesterday I gave you 2 points and said find the slope between these 2 points. Now I'm saying find it at 1 point. So what I'm going to have to do is find a number that's very close to minus 1. And I'm thinking, maybe minus 1.01 is pretty close to minus 1. So I'm going to use that along with the minus 1, minus 9. So the thing that we have to do now is find the f of minus 1.01. And I do need you to help me with this, please, because I certainly can't do this in my head. Here's a function. F of x is equal to this. Plug that in your calculator, right? And by the way, Nicholas, try this even on the calculator you have right now. We can certainly look at what's going on with your calculator, but just see if this will work. So here's what my calculation looks like now. On the top, I'm going to put in the value of the number that I just got. So minus 9.11. I put 111. Okay, I round that off a little bit. Minus the negative 9, which is the other y value. On the bottom, I'm going to put the numbers that I got, which is minus 1.01, which is one number that gave me the 9.111, minus negative 1. Okay. Okay, yes, Shania, please go ahead. Oh, that's true. That's true. So let me take away the calculator now and get back to what we had before. Thank you. Yeah, you're quite right. Thanks for keeping me on my toes there. Thank you. Okay. So we're now back to, by the way, Nicholas, did you try it on your Casio? You notice I'm using a Casio, which is probably very similar to yours. Is it working out any better for you now? I'm just curious. Nicholas, did you try that? You did get 9.13. That's a little far away though. That's a little far away. That's a little far away. All right, we'll figure that out later on in the 3 o'clock hour. Okay, so back to this. Right? So look at what my fraction is, right? My ratio that I'm using to figure this out. Minus 9.111 is what came from the calculator for minus 1.01. Notice that the two first numbers on the top and the bottom are the matching pair. Minus 9.111 and then minus 1.01 at the bottom. Minus the other y value, the starting y value of minus 9. And the bottom, what gave me that minus 9 is minus 1. Okay? So let's go ahead and finish up the math on this now. So I have minus 9.111, and then I'm actually adding on 9 because I'm minusing a minus. So I'm getting from that minus 0.111 is what I'm getting on top. That's what I'm getting. Hopefully everybody has got the same thing. And on the bottom, I have minus 1.01. Oh, sorry. Minus 1.01. Then I'm adding on 1. So that should be equal to minus 0.01. Okay, now I can tell you that for me, if I'm dividing by this, I'm just going to move the decimal point 2 places over. I'm going to get minus 11.1. This is my Iroc. Is everybody getting the same thing that I just got? Minus 11.1. Just checking in with the room on that. I could have made a mistake. That's quite possible. But what did you get? Positive 11.1? Let me just think for a second. Now, was the top negative? Try to remember if the top was negative. Hold on. You could be right. Let me go back and look. Oh, it was negative. Yeah, you're right. You're right. The top was negative. So this should have been positive then. Thank you. Thank you very much. Yes, you're all right that it should have been positive 11.1. Yes, 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 yes. So there's your IROC. Here's your IROC calculation. It's a matter of finding something that's close to the number, the x value that you have, plugging that in, and then doing the same slope calculation. Okay, so let's take this now over to another application in the real world, right? This person who is making basketballs, and again, because we're now applying it to a real world situation, we need to think about units, but we'll get to that. This person making basketballs determines that the profit in thousands of dollars earned on the sale of thousands of basketballs can be modeled by the function. You see the function that's written there. So the profit seems to be rising at some point and then falling at another point, just so we understand this. This number of balls is in thousands. So this 6 that I'm pointing to is not 6 balls, but 6,000 balls. This 80 on the side here is $80,000. So the profit is in thousands, as it says. Profit is in thousands of dollars, and the number of balls is in thousands of dollars as well. So sorry, thousands of balls as well. So that's 8,000, 14,000, and so on and so forth. Estimate the instantaneous rate of change on profit earned on the sale of 5,000 basketballs. Okay, so am I going to put 5,000 into the function? No, because I told you that this is in thousands. So what I'm going to put in is 5 into the function. I think I have this set up on the other page. Here we go. Here's the actual function. All right. It's the same function that we have here, minus 0.9, etc., plus 9. So what I need to do now is find the P of 5. All right, so everybody should have their calculator ready to go on this. It is 81. Yeah, thank you. Okay, so we now need to find another point which is very close to this, right? So I'm going to think 5.01. This is what I'm thinking. right? So we're going to go through the same calculation again, but now we're going to use 5. So I remember, I didn't have to use 5. I could have used 5.001 or something other number like that. I think it's accurate enough to use 5.01. So we're going to do the same calculation again. Minus 0.09 to the power of 3 plus 1.89 x squared plus 9 times x. And I know what I'm getting. What are you getting? For 5.01. All right, I'm going to agree with Janaya on that. Harish is agreeing with that, so 81.2. I'm going to put 81.211. I want to be a little bit more accurate than just that. So I'm going to put what Kayla has. 81.212 actually. When I round that last one there, 81.212. Can we agree on that that rounding there, 81.212? Does that sound about right to you? Okay, so what I'm going to do now is I'm going to set up my Iroc. I'm going to put the 81.212 first, minus the 81, divided by what gave me the 81.212 is 5.01 minus the 5. So always match it up that way. The 5.01 gave it the 81.212. So I'm going to match it up so the two of them are up above each other. The 81 I got from the 5, right? So I'm going to put those two over each other. So that should be equal to 0.212 over 0.01. All right. When I do the math on that, I'm getting 21.2. Okay. So the big question is now, what units make sense? That's the big thing. Let me take you back to what this function represented. This function represents the profit when you're making a certain number of basketballs. They're both in thousands, so they kind of cancel each other out, right? So the profit is in thousands of dollars and the balls are in thousands of dollars. So you say dollars per year, you're on the right track, but you're not quite there yet because you need to ask yourself, what does the P represent and what does the X represent? So it's not profit per year, but give me another interpretation of that. So Janaya is starting off on kind of the right track, thousands of dollars per year. It's profit per basketball. There you go, Harish. It's profit per ball. That's exactly right. So I'm going to put this in dollars as 21 points. I forget what it was. 21.20. $21.20 per ball. That little line there means that it's per ball. Why is it not thousands of balls? I'll tell you why. Because we already have the profit in thousands and we also have the ball in thousands. So those two things cancel each other out, right? You could have said it was $21,200 per 1,000 balls. But then if you just reduce out the 1,000 out of both of those, it just comes back to $21.20 per ball. Okay? Now, does that sound about right? Let's look at the graph and see. Well, for one thing, at the $5 mark, at the 5,000 ball mark, which is right here, the graph is going up. So that would kind of make sense, right? So we would expect it to be a positive. So you are, on each ball that you're making $21.20. That's what that means. That's the profit that you're making on each ball, $21.20. Now, what about when you're at the 18,000 mark, right? So that's somewhere over here. Remember, this graph we're looking at is a graph of this equation. So it's exactly what this equation would suggest. So my question is, before we actually do the calculation, would you expect this number to be a positive number or a negative number at the 18,000 mark? Harish and Joel think it's negative. Really? Is that true? Carissa also thinks it's negative. Are they all right? What do other people think? I'm not going to confirm it or deny it. right? Because it's going down. Okay, all right. So you're on to me. You know what's going on. You know what time it is. All right. So we're going to do that calculation right now, right? So the same formula, right, that we have here, I'm just going to clone this formula. And let's put that further down the page. And we're going to do this now for 18,000. So I'm going to first of all find the P of 18. All right. So you all have your calculators there. Put your calculator fingers to work. And I know what I have. I'd like to hear what you have as the P, the profit at 18,000 balls. Now, by the way, just understand that because you're getting a positive number, this firm is still this company making these basketballs is still profitable because they're still making a profit of whatever number we're going to get right now. And what are we getting, by the way? What's the profit on 18,000 balls? 249.48. I agree. Right? That's a profit of $249.80. That's not per ball. That's overall profit. That's not per ball yet. That's not a rate yet. That's just a profit at the 18,000 mark. So we're going to do the same thing again. We're going to find a P. Again, I'm going to use 18.01. That's the choice that I make. Right? So what I want you to do is to take that same equation and work out what 18.01 would give you. And I'm going to just wait until I hear from you on that. Go ahead and plug that number in and see what you get this time. 18. And you could have decided to go, instead of 18.0, you could have said, I want to go with 17.99 or something like that. That's also good enough. Okay, so I'm hearing 249.375. 249.375. Okay, and everybody else seems, okay, Elizabeth has a different number though. Elizabeth or Liz, can you just check again? Because you could be right. Oh, I see what you did. You rounded it too early though. I think you should have probably kept it at 3. I see what you got. I think you should keep it at 3 decimal places for now. Right? That's that would be my advice when you're doing these Iroc calculations. Put it at 3 decimal places. So 249.375, I think, is going to give you a better answer, especially if you're using 0.01. So watch the calculation again. I'm going to put the 249.48 first. And I'm going to put the number that gave me that underneath it. Minus, see, I'm trying to make sure you keep them in the right order. Minus the 249.375 minus the number that gave me that, which is 18.01. Right, so I match them up that way. So the number that I got from the 18, I put that first. Then I put the 18 under that. The number that I got from the 18.0, and I put that second. And I put the 18.01 under it. Okay, so let's see now. I'm going to go ahead and take the 249.48 and minus from it 249.375. I'm getting 0.21. If you're not getting the same thing, you let me know. No, that's not right. That's not right at all. I need to press this first. 0.105. Okay, that's on top. On the bottom, I have minus 0.01. So to me, that looks like 10.5, but negative. And that's negative dollars per ball. No, I want everybody to be clear on what's going on. This person is still profitable from the point of view. Let me take you back to the graph again. At the 18,000 ball mark right here, this person is still profitable. Why? Because the profit function is above the x-axis, right? At that point, you're making, well, we worked it out a while ago, you're making about 200 and, where is it? You're making 249, basically $1,000 if you move the decimal point 3 places over. So you're profitable. But what seems to be happening at this point? Why is this negative? Right? Let's see if anybody can understand what's going on with this company's operation. Right? What does this negative 10.0, sorry, 10.5 per ball actually mean? Does anybody subtract the 10.5 from the 21? Mm, you're losing profit on that particular ball. You're still profitable, right? But that particular ball, that 18,000th ball that you're making, Harish, is on the right track, right? You're losing money on that particular ball. So what you're doing is you're eating up into your profit. Your profits are going to start dropping. So you're positive, but if you continue making more and more, look at what's happening to this graph, right? If you continue making more and more of these balls, eventually you're probably going to end up in negative profit territory, somewhere under the x-axis. So you're still profitable, you're still making money, but the last ball that you made, that 18,000th ball, was actually eating into your profit, right? Your profits are going to start falling, which is why your profit is falling, right? That's why the graph is going down, because as you produce more and more balls, you start to lose money on each ball, right? Hopefully that makes sense. I just want to check in with the room on that, right? Let me just sort of ask a few people. Again, I'm not asking you a question. I just want to know if that makes sense to you. Neil, how about you? Does what I just said a while ago make sense to you? You're still profitable, but there is a decrease in profit. Yes, so your profits are dropping at this point. That's what I'm saying, right? And that's why the graph is going down, by the way, because every ball that you're making is now a money loser, right? When you get to the 18,000 ball mark, because your costs are probably going up or something else is going on that are causing you to lose money on that ball. Does it mean that you're not making money? No, you're still making money. You're profiting, but there's a decrease in profit. Yes, your profits are falling. That's why you're on the negative side. That's why you're on the decreasing side of the profit of the profit graph or the profit function, I should say. You're still profiting, but the profits are dropping. And you're losing money now at a rate of $10.50 per ball, right? I wonder if that makes sense to everybody. I just want to make sure. I think it was Neil I was asking for a while ago. Yeah, Neil, how about you? What do you think about that? You understand? Okay, that's good. Okay, so let me sort of throw one at you now, right? Let me see if you can do this on your own. Let me give you another number to play with here. Let's go with 12. Now, I hope you can understand that at 12, and I want to see what we can predict what's going to happen before we actually do the calculation, right? Let's talk about 12. Don't do the calculation yet. Would you expect the 12 at the 12,000 ball mark still increasing? So should the profit per ball, the rate, the Iroc, should that be a positive number or a negative number? What do you think? So Emily and Joel and a lot of people are thinking it's positive. Excellent. Here's my other question. Before you actually work it out, we worked out the profit per ball. Oh, sorry. We worked out the profit per ball initially at why is this at 6? It should have been at 5. Yeah, it's supposed to be at 5. This line is wrong. Let me remove this line. And before you do the calculation, let me put it in at 5. Right? We worked out that at this point at the 5, the slope of the line there was about 21.20. So that means it's that the profits are increasing at $21.20 per ball. Okay, so we've all agreed that if we're still pushing it up to the 12,000 ball mark, that's going to be positive. Would you expect that number to be bigger or smaller in terms of it being positive compared to the 5,000 ball mark? Just comparing those two figures. Okay, so we know it's positive on the positive side, but would you expect that number to be a bigger positive or a lower positive? That's the thing I want to ask you. What do you think? You think it's going to be bigger? Emily and her. Okay, we got some lower, we got some bigger. Okay. All right. I'm not gonna say anything more until we actually get the numbers. And I'll tell you why the number is what the number is after you work it out. Because I know whether it's gonna be bigger or smaller, and we will see after work it out. So Janaya and everybody else, Karis and Aksa and Harish and Kianti and Emily and Joel and Karis and everybody else who chimed in, hold your fire, work it out, then we're going to talk again. So I want you to go ahead now and do a Iroc, an Iroc, instantaneous rate of change, for the 12,000th ball. So we do the same calculation. We'll leave the conclusions out for now. I want you to do this for 12,000 balls. And you're not going to put 12,000. You're going to use 12 instead of 12,000. Okay? Can you scroll up? Oh, I sure can. You're going to need the equation for sure. Let's try. Let me put you on this page where the equation is a lot easier to see. Okay? So I'm just going to randomly ask one of you for what you got as your answer. And that goes to Eliza. Eliza, let's hear what you got. Let's hear what you got. And then we're going to see what other people think about what you have. Eliza, you're there with us? Where's Eliza? Where is Eliza? Huh, what's Eliza, where is Eliza? All right, for some reason, I don't even see her in the room, and I didn't mark anybody absent today. All right, we're going to have to figure out what happened to Eliza in a minute. Let me find somebody else in the meantime. All right, so ready? We'll get back to Eliza later on. All right, so hall pass. Okay, Ava. Yeah, ready, go ahead. Okay. 15, exactly 15 or close? Exactly 15? Okay. I got a little bit different answer, but it's on the right. Yes, Janaya, please go ahead and Jeremiah. Let me hear what you both got. Go ahead. Yes, go ahead. Okay, good. And what did you have, Jeremiah? Oh, for the yeah, I got you. Oh, to make it more accurate. I hear you. I hear you. Okay, that's interesting. Gotcha. Gotcha. No, I'm not going to say that Rita's answer is wrong at all because it's not bad, right? My answer was 15.5. And remember, this is dollars per ball. Let's talk about that. When I asked the question earlier on, and I said, what would you expect when you compare that to the 5,000 balls? Some people are saying it's going to be higher, some people said it were lower. Now, we can see from the answer that, thank you, Keontae, 15.5. So we can see from the answer it's actually lower. It's actually lower. Let me see if I can explain. Okay, does anybody want to hazard a guess as to why that is? All right, let me clean up the graph a little bit to see if we can, before we finish today, sort of talk about what's happening on this graph. Can anybody see why they? Okay, Janaya, go. Mhm, mhm. That's interesting. That's an interesting observation. Okay, does anybody have another observation that they think they want to share with us? Why do they think? Thanks for notifying me. Does anybody see another way that we can look at this? What I'm probably going to do, we have a very few minutes left. I'm going to put this graph in Desmos, and I'm going to share my Desmos screen with you. But does anybody have another? Just out of curiosity, what should we say if a test question asks us what conclusion we should draw from the values found? That's what I'm going to try to answer for you right now. I'm going to see how quickly I can put this in a Desmos screen and share my Desmos screen with you. So let's see now. Actually, no, the best thing to do would be use WinPlot. Yeah, that would probably be better if I can find my WinPlot very quickly. Hang on 1 second, folks. That might take some time, though. We'll see. We'll see how quickly we can get this done. All right. You know what? Rather than me trying to get some other screen, let me show you why the number is lower. If you can kind of, so you should still see my graph on your screen. Yeah, you should still see my graph on your screen. Are we getting a test review sheet for the weekend? I believe there is a review there already on the Math Video Library. I can check for you in a minute. But you also have the textbook, and there is a test review there in the textbook. Right? There's a text review. There's a review for the entire first unit right there in the textbook. Okay, but I believe there's a test review on the Math Video Library as well. Okay, very quickly, if you can think of a tangent line up against this function. In fact, I'm going to grab a line right now from the tools that are up there. Think about a line that is touching the edge of the function, maybe around here. As you slide, as you slide that line up, notice that for you to make it a tangent, you have to kind of flatten the line up a little bit as you get closer to the top, right? And as you get even closer to the top, this line, if it's going to be a tangent, is getting flatter and flatter and flatter. So it looks like as you go to the top of this peak of this maximum, the line is actually flattening out. Compare that, because I couldn't put that tangent line here because it's not steep enough. I'd have to make it much more steep for it to be a tangent line here. But once I get up to here, for it to be a tangent line, it now has to flatten out. All right, so now it's a flatter line. And once I get to the top, it's very flat for me to be a tangent line. On the other side of that, on the other side of that, the tangent line starts off being fairly flat, right? But as you get further and further along, that tangent line now has to become more steep. Sorry, folks. I'm trying to do this very quickly here. So if I did an Iroc at the top of this, it would be a fairly flat negative number. But as I go further and further along, it's going to actually get more steep. So that's what I was trying to point out to you. So at the beginning, when we were at 5, right? So, when we're at 5, right? A tangent line, I don't know why I keep putting 5 here. 5 is over here. At 5, it's a fairly steep line, but as you get up to 12, that line that line is now flattening out. So it's going to be a less steep rate of change. Does everybody see what I'm saying here? Because we're at the 240 mark. And folks, disappointing as it is, I know that you're going to be bummed out for this for the whole weekend. I'm not giving any homework. I'm sorry about that. I know you're probably going to, be really, really disappointed for the whole weekend thinking, no homework, what am I going to do? I know. But anyway, I thought that you guys did a good job. Plus, I want to give you time to work on getting ready for the test anyway.